Hello everybody and welcome back. We're taking a look at the 2003 Pascal competition and we're up to question number 13. So hopefully you've had a chance to take a look at it. I'm going to take a look at it now. Question 13. In the diagram, each of the 15 small squares is going to be colored. Any two squares that have a vertex in common or share a side must be a different color. What is the least number of different colors needed? Okay, my instinct, just from reading about math and things like that, is probably 4. There's a very nice result called the 4-color theorem, which basically says any map or anything like that can be colored so that each sort of country or region, or in this case squares, is where am I going with this? It can be colored so that each country or region is a different color from any of its neighbors using at most 4 colors. Okay? So I see a very squarish, rectangular looking map with very square looking countries. I think the answer should be 4. Okay? 4 or 3, but shouldn't take me any more than that. And that's just from general pop math, knowing things about math. Okay? If you go on, and this is the grade 9 contest, so maybe you aren't thinking about this, but if you go on to get, say, a university degree in math, or even just look into things, the field of combinatorics on your own, you will eventually run across the 4-color theorem, graph theory, all that fun stuff. Okay? But if you don't know any of that, let's just investigate the question as is. If you do know the 4-color theorem, this is probably a nice application that you've narrowed it down to 3 or 4. Alright, let's draw our 15 squares, our 15 little countries, our parcels of land, and to see what we can do. We've got colors. Always a good idea to bring some pencil crayons to a math contest. You never know when you might need to color something. 1, 2, 3, 4. 1, 2, and that's it. Okay. So I'm not super exact. If I was using the graph paper, I probably could have been a little smarter about it. Okay. I'm going to color this square here blue. The second I do that, I know that this square here has got to be a different color. Okay? Now let's look at the other ones. I know that this square here can't be blue because it's touching, it shares a corner with blue, and they said that's not allowed. And it's sharing a side with red, so it's got to be a different color too. And this fourth one here, it's touching green and blue, so it can't be colored green or blue. And it shares a corner with red, so it certainly can't be the red either. So we've already got 4 colors. And we've already eliminated our answer of 3. Okay? So we know the answer is going to be 4, 5, 8, or 9. Okay? Now if we keep going, we might find a way to say it's got to be at least 5 colors. Then maybe at least 8 or at least 9. On the other hand, if we can now find a way to use just these 4 colors to finish coloring it in, well, that's the least number of colors. It can't be 3. It's got to be at least 4. But if we can show that it can be done with 4, 4 is our answer. Or if we can eliminate 4 and show that it can be done with 5, then 5 would be our answer. 5 would be the least number of different colors needed. And that's what they're asking for. So let's see if we can complete this a little bit. We've got 4 colors already. Let's see if we can very smartly figure out a way to keep going. I'm going to put a blue here, and a blue here, and a blue here, and a blue here, and a blue here. I'm going to put a red here, and a red here, and maybe you can see what I'm doing. I'm just taking this little square of 4 different colors, and I'm repeating it over and over again. And you'll notice that it works. At every vertex, we've got 4 different colors, and all the sides have different squares with different colors. So we notice that 4 is needed, maybe more, but now we've got that 4 works. 4 is a possible answer. That tells us 4 is the least. And we could have found that out just playing around with colors. And so that's an answer of B. Okay? So the four-color theorem, as predicted, gave us the right answer. But I didn't invoke that in my answer. I just started coloring, realized you've got to have at least 4, blue, red, orange, green, and then I found a way to repeat it. Okay? And that gave me that 4 colors will be enough. Not a bad little question. In the next video, we're going to look at question number 14. So hopefully you'll join me for that one.